This video is all about how we do enlargements to shapes. So this is the final one in our different series of transformations. So what an enlargement is it makes a shape bigger or smaller. And we're going to begin this by using what's called a scale factor. Now a scale factor tells you how many times larger or smaller each length gets. So if you've got a scale factor between 0 and 1, when you multiply each length by a number between 0 and 1, it'll make it smaller, and so the shape will be smaller. If you have a scale factor bigger than 1, then when you multiply each of the lengths by a number bigger than 1, that will make them bigger. And so if the number is bigger than 1, the shape will be bigger. If the number is between 0 and 1, the shape will be smaller after it's been enlarged. We still use the word enlargement, even though it reduces in size. So we're going to go through two examples of these, and what you can see is we've got this L sort of shape here, and this is our object, our starting shape. Now what I'm going to do is I'm just going to write some bits on the shape to help me with my enlargements. I'm going to count the squares as I go around the outside of the shape. So you can see that I've got a 1 unit across there. I've got 3 squares down, 2 squares across, 2 down, 3 across, and 1, 2, 3, 4, 5 squares up. That's to help me, when I'm drawing the enlarged shape, work out what each length is going to be after it's been enlarged. So I'm going to start now in this top left hand corner of my shape. I'm going to just choose an arbitrary point to start with there. And if you look, the original length is 1 square. Because I'm using a scale factor 2, SF standing for scale factor, that means the new length across the top is going to be 2 squares. Now obviously you're going to use a ruler. I'm going to be a bit lazy here and do it as a sketch, but I'd like you to do it as a ruler, using a ruler please, for your own. Right, now if you're going down here, it was originally 3 squares, so we're going to go down 6 squares. So 3, 4, 5, 6. And then we're going across 2 squares, so as we double that, we're going across 4 squares. And then we're going down 2 originally, so it's going to be down 4 again. And it's across 3, so double that, 2, 4, 6. And then hopefully this line should join up, and we'll check the measurement in a second. It was originally 5, so it should be double that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it is, it's double. So this is what we refer to as our image, the shape after it's been transformed. Okay, and we're done. So this is our starting shape, and this is our shape after it's been enlarged by a scale factor of 2. The next one then, you'll notice we've got this kind of like a backwards R, I'm going to call it. And this time we're going to use a scale factor of a half. But before I do that, I'm just going to write down the measurements of the lengths as before. So 4 squares up. 1, 2, 3, 4, 5, 6, 7, 8. 8 squares across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares down. And 4 squares across again. And 1, 2, 3, 4, 5, 6. 6 squares across and 4 back. So I've got all the measurements in terms of the squares, because I'm using the squares as my scale here, not centimetres, because these are not centimetre squares. And I'm going to now again choose a starting point, I'm going to choose the top left hand corner, and I'm going to go around the shape clockwise. So it goes across 8 squares originally. So 8 times a half, well that's like finding a half of a value if you times it by a half. So a half of 8 is 4, so it's going to be 4 squares across. The next length is down, and I'm going to go 10 squares down in the original shape. So 1, 2, 3, 4, 5 squares on my enlarged shape. 2 squares back because it was originally 4. Half of 6, or 6 times a half, is 3, so it's going to be 3 squares up. And then 4 squares back, so half of that is 2. And half of 4 is 2 back up. Now obviously yours are going to be done using rulers and nice straight edges. I'm just giving you the idea and the principles behind our enlargement. And that's our image after we've enlarged it by a scale factor of a half. Okay.